and how that could help and benefit your research. My name's Jenny Wong. I'm a research software engineer within the Advanced Research Computing department in the university. And I, along with my teammates, we provide the BEAR service, which is the Birmingham Environment for Academic Research. So just to give you an overview of what we're going to cover today, I'm just going to give you an introductory talk into AI software and the tools that are available for you to use at the University of Birmingham. And then we're going to have a few user case studies with people's experiences of using this software in their own research. So we've got a case study by Claire, and we've got a case study by Bindi and Bowen. So thank you for making it today. And I'll just get started with the introductory AI software and tools talk. So AI is quite a broad term. It's been used a lot recently. It's quite popular. It's permeating a lot of different research subjects, not just within business school, but it's been widely used in physics departments, computer science. And I just want to sort of narrow down what people mean by artificial intelligence. So this could refer to machine learning, for example. So machine learning sort of broadly looks at two classes of problems in a sense. So the first set of problems could be a classification problem, for example. So just to take a very simple example, say you want to classify, I don't know, apples versus oranges, or in a business school context, one company from another, or a size of a forest compared to another forest. You might be able to sort of want to be able to classify those clusters. So this is one type of problem that machine learning can help you with. Another type of problem that machine learning deals with are regression problems. So you might have a set of inputs and you want to predict an output, and in order to do that, you need to perform some kind of regression. So in this simple example here, we have linear regression. So you have all of your data points here, and you want to create a trend from it using a regression line. So another simple example of that might be, number of goals scored versus winning a trophy. So, if you have more goals scored, then maybe you've got more chance of winning a trophy, for example. I'd just like to clarify that my domain knowledge isn't in the business school. So I'm just using very fundamental concepts to kind of illustrate these problems in machine learning. And then the other sort of class of models that are used in artificial intelligence are deep learning models. So the applications for these, rather than a classification or a regression problem, for deep learning, they can be applied to machine vision problems. So for example, in this diagram here, say if I have an image of a cat and I want to classify that cat, this image is not like a data point on a graph. This is an image that is 2D and there's colors involved as well. So you need to be able to feed that input into a deep learning model and then classify the outputs. And a deep learning model is inspired by how neurons work in the human brain, for example. So a deep learning model could be composed of lots of different layers, each with many, many different neurons, and each neuron is activated given a certain weighting. So when you put in, for example, this image of my cat into this convolutional neural network, what this does is tries to extract very low-level features from this picture. So things like, straight lines. And then as you add more and more layers to it, that can capture more and more complexity within the picture. So you might have another layer to the model. And that's why it's called deep learning, because the deep refers to the many hidden layers within this neural network. And then at the end of it, you want your neural network to then make your classification. So yes, it's a cat, or no, it's not a cat. So I'm using a simple example of a cat here, but perhaps in your research, you might want to be able to process images in your own way. So this is a really powerful and fundamental thing that is at your fingertips in terms of the resources that we have available here at the University of Birmingham. So I want to just kind of describe the resources that we have here available. So one is called BlueBear, and BlueBear is the high performance computing supercomputer here, and it's managed here. So it's an institutional cluster. So every student and researcher is able to access this facility. So all you have to do in order to access it is you need to register for a project through your PI, and then also have a Bare Linux account. So the barrier to access is very low here. And in terms of the compute resources that we have on BlueBear, we have 180 nodes with many CPU cores available for you to use. In terms of GPUs, there are about 6 GPUs spread across 4 different nodes. And then if you do have a Bare project registered with us, each project has 3 terabytes of data storage for you to use, which is a healthy amount of data. However, you might want to note that in terms of GPUs, we're quite limited on our BlueBear institutional cluster. And one of the things about deep learning models, for example, they're very well suited to GPUs. So it takes a long time to train these deep learning models because you've got to feed it that data. That model learns what a cat looks like and then gives you the output. That training process takes a very long time computationally. So you might want to consider accelerating your workflows and doing those computations faster with a GPU. And I'd just like to point out that we also have a facility called Baskerville that's also available for you to use. And this is actually a national HPC facility. So it's not just the University of Birmingham that uses it. There are other partner institutes that also use this facility, so it's shared across others. But to use Baskerville, because it's exclusively for GPU computing, then access to it requires an application. But it's the same process as what you would go through BlueBear. So you would go to the IT service desk and log a request through your PI. So as I mentioned earlier, Baskerville is focused on GPU computing, which is in terms of if you want to train your models, it's much faster. So here you can see the difference in the resources. So we have less nodes on Baskerville. So there's 52 nodes, but each node has 4 GPUs. So there are 208 GPUs in total that you could potentially use on Baskerville. And then in terms of storage, you have 1 terabyte of storage per project. And I've got a couple of links to further information. So if I just click on this link on our intranet pages, you can see all of the information that you need to know if you want further details on BlueBear. And similarly, in this link, there are more details about how you can access Baskerville, how to request a project, and I'll provide these PDFs to you after the seminar so that you can access these links yourself. Okay, so I'm just going to move on to the software packages that are available in order to carry out some of these AI workflows that you might want to do in your research. And so I'm going to firstly go through Python. It's the most popular language when it comes to AI, machine learning, deep learning tools. So you may or may not have heard of these packages before. So the first one is called TensorFlow, which is quite geared towards deep learning, and it was originally developed by Google. And then you have TensorFlow is quite difficult to use in a sense, but you can use it in conjunction with Keras, which is a wrapper essentially that talks to TensorFlow. So these are two quite popular packages for deep learning workflows. Alternatively, for deep learning, you can also use PyTorch, which was originally developed by Meta AI, formerly Facebook. And then for machine learning tools, scikit-learn is an extremely popular package on Python. So if you want to, again, do classification problems or regression problems, there are many, many different algorithms in scikit-learn that you can use in order to solve them. So k-means testing, cluster analysis, support vector machines, etc. And then there are also a few other handy packages that are not directly machine learning related, but could be beneficial for speeding up your computation, because it does take a long time for your models to process all the data that you might be giving it. So one package that is quite good is Dask, which helps you schedule your computations between different cores and even different nodes. So I don't think I really explained what a node was earlier. A node is basically a sort of a subcomputer of a larger supercomputer. So if you want to use multiple nodes, i.e. multiple computers across the HPC system, then something like Dask can help you handle all of the data input-output management of that. And similarly, Horovod does the same thing. It helps you distribute and schedule and scale out your work. So these are sort of just a vague, there's plenty of other packages as well, aside from what I've highlighted here. But I would say these are the most popular packages when it comes to deep learning, machine learning software. I'm less familiar with R, but it's definitely very, very popular and is actually growing, I think, as a community. And I think just doing kind of some cursory research, there has been some like specific tailored packages that deal with econometrics. For example, there is one package available called AER, which is applied econometrics with R. And R also has lots of different packages you can download through their CRAN network as well. So if you go on CRAN, you can also see packages like QuantMod as well, which deals with quantitative financial modeling. There's a package called Survival if you want to do survival analysis. Another package called T-Series if you want to look at time series analysis. So again, this is just kind of a bit of a highlight of the different types of packages that you can find using R. So I'm going to do, hopefully, I hope it works, but a little live demo of Python packages and R actually on Bluebear portal. So I don't know if you can see the link there, but if you go to portal.bear.bham.ac.uk, you'll be able to access a web browser that allows you to use the Bluebear supercomputer. So I'm just going to change screens to what you would see here. So at the top in the address bar, you can see I'm on Portal. And if you look at the top here, you've got a place where you can go view your files in your project directory, where I mentioned that you get 3 terabytes of data storage. You can make jobs. You can also access a terminal through here if you click on this link. But what I want to show you today is this tab called Interactive Apps. And so through here, you can launch a Jupyter Lab server or an RStudio server. I'll start with an RStudio server at first. So when you click that link, it brings you up to this page and it asks you for the type of resources that you want in order to launch an RStudio server. So it'll ask you for your project name and then the number of hours that you want this server for, because on a HPC system, you're sharing the resources with many other people. So you have to specify like how long you want it for. And then you've got a queue to define, and there's some text here to explain what all the different queues are. And you can specify the number of cores that you want and the version of R that you'd like to launch RStudio with. So I have actually created one earlier, a session earlier, so that I didn't have to queue, but this is a live demo, so we may have to do some waiting. Okay, perhaps I have to click on this just directly through here. Okay, yeah, so when you do launch a session, what happens is you'll see this window here. And then once your job has queued and it's running, so for here, I've got an RStudio server running, and then I click this button to connect to that RStudio server. And then this launches RStudio that's running on Bluebear. So it's not running on your local computer, it's running on Bluebear. So you have all of the computational resource that's behind it here. And yeah, here is your typical RStudio IDE here. So in the top left corner, here is a script that I have. In the bottom left corner, this is a console. And the top right will tell me about my environment. And then the bottom right is my file explorer. So I've got an example within here. So yeah, here are all the examples that I'm going to show you today. So in this script, what I'm doing is installing some packages. Wait, so I can't remember if this is already, if I execute. Okay, so if I execute this, so in this particular script, I'm just loading up a data frame from this package that I've installed. And then I'm executing each line, and you can see the output of the execution in the console in the bottom left-hand corner. And then if I'm in this particular example, in this R script, I'm doing just a very simple linear regression using ordinary least squares. So in order to do that, I'm just taking the covariance of two different variables. So in this data set, I've got two variables called rho, which is the return on equity, and a salary, a CEO salary. So if I execute this line, it gives me the covariance. This line gives me the variance of the return on equity. And then I'm calculating some means. And then I'm calculating the coefficients for my linear regression model. So that's done in lines 16 and 17 in the script. And then I want to actually create a linear model in R, which is done in line 20. That's what the LM function is for, linear model. And I'm saving it in this variable CEO regression. And then this is how you would create a scatter plot. Oh no, I've got a warning now. Okay, I think I need to execute this. Right, let me try this then. And there you go. So I've got, can you see in the bottom right-hand corner, I've just created a scatter diagram. And then if I want to add the regression line that I've calculated, I can just execute this AB line function. And it draws the regression line through the scatter plot. So this is on the x-axis return on equity, and then on the y-axis is the CEO salary. So that's just one very quick and simple example of using RStudio on Bluebear. And then the next demo that I'd like to share is one on JupyterLab. So again, if you go to interactive apps, and then if you go to JupyterLab this time, you'll get a similar form where you have to request the resources, as well as load a particular kernel of Python, a specific version of Python. And then again, here's one I made earlier. So once you do launch the server, you'll see a card that looks like this, and then a button that tells you to connect to Jupyter. And now I'm running an instance of JupyterLab on Bluebear. And it takes a while to spin up. And this is what a JupyterLab notebook looks like, for example. So it's a bit more involved when it comes to setting up your environment here. For example, if I wanted to use scikit-learn in my JupyterLab notebook, I have to load the relevant module. So in order to do that, if you look on the left-hand side, I've got this file symbol to see my folders, but if you look at the blue square, this is where you would load the modules. And as you can see in this really long list, there are plenty of modules that you can load. So in this particular classification problem, I'm using scikit-learn. So in order to make that available, I have to module load scikit-learn, which is over here. So if you can see, there is the software that I want, and then I click the load button. And then if I go back up to the top, these are my loaded modules. And if you wait a little while, you can see the loaded modules have just updated. And there is scikit-learn, and it's brought in all of the other dependencies that scikit-learn needs to work as well. And then for scikit-learn to be available, oh yeah, I do have to load in matplotlib, sorry, I'm getting ahead of myself. That is another package that I need to load for this notebook to work. So if I just look down my list and look for matplotlib, here we go. So matplotlib is a plotting package that's commonly used in Python. So if I want to run my notebook, I need to make sure that that is available in my environment here. So if I go back up to my loaded modules and just check on my list, I've now loaded matplotlib. And then you've got to restart the kernel because we've just loaded in a whole load of software. So to make it available in the notebook, you've got to restart your kernel. I know this is a lot to take in at first, so please feel free to refer to the recording of this seminar afterwards. But it's just to give you a flavor of like what it's like to actually use this software in a live demo. Okay, so now the kernel should be available. And then if I execute this cell, that imports the packages so that they're available for this notebook. And importing software can take a long time because software packages can be quite large as well. So, okay, yeah, so that's just imported. And then in this particular notebook, what we're doing is using machine learning to recognize handwritten digits. So if I just run these cells, this is the data that's given to the machine learning model. So this is a data set of handwritten digits. And what this notebook is doing is using a support vector classifier to differentiate the different digits. And here what we're going to do is make some inferences. So in this plot here, from this image, the model predicts that this image is saying 8. Same thing here. This model thinks this looks like an 8. This one looks like a 4, and this one looks like a 9. And yeah, I think that looks pretty accurate. But you can actually look at the statistics of how accurate this model is using a a certain function. So it tells you about sort of the average accuracy. So apparently it's 97% accurate. And this, I've just done this all live just now, by the way. So it doesn't take a huge amount of computation for these kinds of machine learning models. And then this is quite helpful as well when it comes to quantifying the uncertainty of your models. So this is a confusion matrix. So in the x-axis, this is what the model predicted. And on the y-axis is what the true number was. So you can see, there's pretty high accuracy when the model sees a 0, it thinks it's a 0, and it's actually a 0. So as you can see along the diagonal, you've got the accuracy values. But here, so for example, the number 9, you can see that the model gets confused, the number 9 with the number 4, for example, or it gets confused 9 with 5, but very occasionally. So that's pretty nice. And all this functionality is very basic, what I've shown you here. But think about the potential of what it can do for your studies too. I think I'm slightly running over time. So I think I was going to show you a deep learning model, but I think I'll call it there and take some questions before I pass over to the case studies. So yeah, any questions? How many of you in the room already use BlueBear or no, or not? Okay, yeah, the speakers definitely do, yeah. Okay, great. So if you don't use BlueBear, think about it. It's very easy to access. Talk to your PIs about it. And, it's just generally quite useful to have to offload your work onto a supercomputer, because your laptop or your local machine can get very occupied. If you're processing lots of data, it's nice to be able to just ship it to a remote HPC cluster and run it on there, so that your laptop is free to do other stuff. That's the general gist of it, I guess. But yeah, I hope the following case studies will sort of inspire you to use BlueBear, or potentially Baskerville as well, if you need more accelerated computing. So yeah, Lindsay? Yeah. Yeah, I guess it's the same and it's not. If you want if you want to be very fast and want something that's very well optimized, then using the Linux interface would probably be the best way of doing it. So you're familiar with Slurm and submitting a batch script, for example. So that would be probably the fastest and most optimized way of running code. But for those who are not so familiar with the tradition, that is like more the traditional HPC workflow. But for those who are not familiar with that, then the browser and the interactivity is easier for people to sort of get on board with, because it replicates what you do on your local machine. So it really depends on what type of work you want to do. If you've already tested your code and you know that it's giving you, that everything's fine, and you just want to ship it off and do the computation, then a batch script, a batch job would be the fastest way of doing it. If you want to do a lot of testing, you want to see some feedback and more visual, outputs, then a notebook would be ideal. So, and more friendly, yeah. Okay. Yeah. If a test in your own code takes a long time, would it be better to use the HPC? Yeah, you can use the HPC for testing. So for example, I think if you look on the resource request form, so for example here, JupyterLab, I don't know if you noticed like these different queues. Oh no, we don't have a BB-shot one. Anyway, yeah, like you could perform tests on a very short job. Say if you ask for like 1 hour and like maybe a couple of cores, you could still do that on the HPC. And it's probably easier to do it on the HPC because then when you want to accelerate it, or you want to do the full simulation, then it's easy to scale from your test to the full-blown run. Yeah, because environments can be a bit tricky. So trying to replicate the environment on your laptop you might not be able to get the exact same environment on the HPC. So developing on the HPC is, I would say, quite recommended so that you can, yeah, have the same environment. Okay. All right. I think we're coming up to past, so I think it's best I hand off to the next talk. So Claire, would you like to speak? Okay. Yeah, this is for the so there's a clip here, and there is a clip for you. Thank you. Yeah, thank you. Yeah, thank you.
Yeah, thank you, Jerry. Hi, I'm also very happy here to meet all of new PhD students as well. Yeah. And actually, I use the interactive app and also, upload the document to Bluebear. I use them both. I think they are almost same. The thing is, for the interactive app, they can actually be more environment friendly for the package things. Because for like when I run my program, when I upload to Bluebear, it really took me for a long time, like a month, to solve for the environment things. Really. But you use the interactive app, you're gonna solve. But the thing is, for interactive app, for example, you can open like 10 windows. It's okay. But if you need to separate them into like 100 package 100 times to run it, it can be very tricky. So I think currently, if I use just for like 10 times, I can just open 10 windows. But if I just need quite a lot, separate them to 100, I can just upload them to Bluebear. So that's what I did. Yeah. So hi, I'm Claire. I'm from the Department of Economics. So this is my today's topic: textual analysis and machine learning in my economics research. Bluebear helps. So basically, in my research, I use textual analysis. So I use text data, I use news data, and I use machine learning techniques. And in this progress, Bluebear helps me a lot. Okay. So today I'm gonna first present my paper, and then I'm gonna introduce how Bluebear helps. Okay. So this is my paper, Measuring Brexit Uncertainty, a Machine Learning and Textual Analysis Approach. And this is a joint work with Wanyu and Rob. And currently, this is already a CEPR working paper, so you can actually find it online. Okay. So the term Brexit first used in May 2012, and it has resulted in substantial and protracted uncertainty from the pre-referendum era to the current post-Brexit period. Okay. However, there is lack of timely measure of the uncertainty, and especially its topical components. For topical components, I mean, for example, the employment, trade policy, and like manufacturing or like immigration things. So in this paper, we construct aggregate and also topic-specific use-based indexes of Brexit uncertainty for the UK economy using machine learning techniques from computational linguistics. Okay, so our indexes start from 2013, is a monthly one. And the main idea behind our indexes is just that we use the frequency of relevant newspaper coverage to proxy for the indexes. So basically here, the machine learning model helps to find the relevant newspaper coverage. Okay, so basically our methodology have 2 steps. Okay, in step 1, we first construct aggregate BUI, so aggregate indexes. Here we apply word-to-vec model. So this model would identify Brexit, uncertainty, and UK term sets to filter out Brexit uncertainty related articles. So basically, we believe that an article containing a word indicates Brexit, and a word indicates uncertainty, and also a term indicates the country UK would be Brexit uncertainty related articles for UK. Okay, and then step 2, we try to construct our topic level BUI. Here we use an LDA model. So this model would automatically extract topics of Brexit uncertainty, for example, like Northern Ireland supply chain. Okay, and also map news contents to the topics. Okay, and also it can be very easily to update with this model. And we also control for the uncertainty due to the COVID pandemic, because we know that, especially in the post-2020 period, the COVID and also Brexit, they simultaneously contribute to several issues like supply chain and also employment, right? So it's very important to control for it. So we do it. So as for contribution, we have 3 main contributions. The first one, it provides a real-time and cost-effective Brexit uncertainty measure that covers the entire Brexit process, this pre-referendum and also the post-referendum. Okay, and also our aggregate BUI can be flexibly broken down into topic-specific components. Okay, it's going to facilitate systematically examining the effects of Brexit uncertainty in specific areas. Okay, and also we find that the main source of uncertainty are Northern Ireland, trade policy, and immigration. And third, our paper is the first to disentangle the effects of the COVID pandemic from Brexit. We actually find that the COVID exaggerate BUI by 1.5 times, and with most significant effect in employment, government spending, and supply chain. So the main advantages of our methodology with the machine learning techniques are the 5 points. The first one, it allows for topic level BUI, capturing evolution over time. And second, it can weight each article when measuring topic BUI. So here we have the main idea. The idea is that for each article, they can include multiple topics, right? They can have 20% is about immigration, they can have 80% about employment, right? So with these machine learning techniques, we can detect this weight. Okay, we can extract this share. And also, it's very cost effective in terms of labor and financial costs, and also long time spent compared to survey. Because now the mean measurement for Brexit uncertainty are based on survey. But we know that survey is actually costs a lot. It costs a lot of money and also labor costs, right? And also with machine learning techniques, we can reduce subjective judgments and also accounts for more words. Right. So theoretically, with machine learning model, we can account for all words for news. Okay. And also, it's very easy to update. So in this study, we use news data. Our news data is from 11 leading UK newspapers. I also jump here to step 1 that we construct the aggregate BUI, and then we construct topic level BUI. So the LDA model will mainly have 2 outputs. The first one is topics. Topics are not just told you that, okay, the topic is about, for example, Northern Ireland or supply chain. No, but the topic is actually in the form of distributions over words. We're gonna see example here. So here are 4 example topics. Okay, so each word cloud corresponds to 1 topic. And based on the word cloud, we need to manually label it. So here for each word cloud, it actually presents the most important 80 words for each topic. So we label them as, for the first one is Northern Ireland. So we label them as Northern Ireland. And this one is, I can say, supply chain and driver shortage. So it's about supply chain. Okay. And for this one, you can say employed job worker. So it's employment. And for this one, you can say pound sterling. So it's macroeconomy currency. That's we manually label it. Okay. So this is the first output of the LDA. Yeah, sure. Yes.
I mean, to find the specific attitude of this topic from the public, or just a number of this course.
You mean how I group them?
I mean, how combine the topic? I mean,
Yes.
so you captures the attitude of the public related.
No, no. Yeah, just the content, just newspaper content, not the attitude. Yes. We perform sentiment analysis later based on the Twitter data, but no, not now. Yeah. Yeah, so this is the first output about topic. And the second output is the topic distribution over each news articles. Based on the second output, we can get the time series share of each topic so that we can have the construct the time series indexes. Okay, so this is our aggregate Brexit uncertainty indexes. You can see here, the black line is our BUI. And also here as a red line is our lower bound BUI after controlling for the COVID effect. Okay. And here's a black dotted line. I put it here as a robustness check because this is the Brexit uncertainty series based on the decision maker panel survey. This is conducted by the Bank of England. Okay, we found a very high correlation. So I put it here to suggest that yes, our methodology is reliable. Okay. You can see the mean spike here of the indexes happened during the Brexit referendum and also the general election. And here the failed manifold walls on withdrawal deal and also further Brexit extension. And here this point is when the transition period ended and when just before the TCAB reached. It's for decision maker panel. So this is a survey just like conducted by the Bank of England. So this is focused just faced to the firm managers like CEO and CFO of the firms. And for example, in this survey, they will be asked, like, do you think Brexit is the source of uncertainty for your business? They will answer like this, yes or no. And they would answer, the Brexit would be the top 3, top 1, or like one of many source of uncertainty for them. Okay, so here for this series is actually get it based on the survey. So it's a extent of the Brexit uncertainty for their survey. Okay, yes. High index, this one. The pink one, that's the Brexit referendum. A Brexit referendum. This is one Brexit referendum. Yes, this means the Brexit uncertainty. So this is the Brexit uncertainty index. Yes. Yes. No. Yes, about the future. It's about the future. It's about Brexit uncertainty. It's actually they mention Brexit uncertainty. They have no idea about what happens gonna be in the future. For example, what happened for the employment or the immigration system or policies or trade policies. Yes.
So the index is the value about the people's attitude towards the future.
And also captured by the newspaper. Yes, I think I would prefer to say it's a newspaper index, but not for public attitude, because if you need to say it's public attitude, it should be like social media things. Yeah, but this is for newspaper, news-based. Yes. Yeah. Okay, 1 minute. For this topic, I would just jump. Yeah, so basically in this paper, we adopt those techniques and we construct those indexes. And also we have a website about our project, and also we released all the indexes in that website. So if you're gonna interested in it, just check this website, okay? And also Bluebear helps. So basically for this progress, if I use my own devices, it needs more than a week, okay? But with Bluebear, it's only about 10 hours. Okay? And also no need to worry about crash. So basically when I use my own laptops, it crashed quite a lot. Okay? So if I crash, I have to restart again. So it's gonna be very, very tricky. So Bluebear also have provide a lot of support. For example, they have beer dropping sections. They also provide like training classes, and also you can send email to them to ask them about questions. Okay, so actually they help me a lot. Okay, yeah, that's all. Any question or? Yeah, thank you. Yeah.
Thank you. Hello, everyone. My name is Binzi Chen, and I'm here today to discuss how Bluebear can help business school research from the perspective of the econometrics. And oops. Yeah. Yes. So the QR code here is my personal website, and I'm currently a third-year PhD student in economics, and my research interest lies in theoretical and applied econometrics with panel data and group patterns or factor models. And I'll show you these details later. So I'm currently working on my second chapter, and for my first chapter, I benefit from the Bluebear a lot. So my first chapter is about the relationship between economic growth and the income inequality with the model proposed by Bonomo and Marisa in 2015, which is called group fixed effects model. So you can see that compared with the traditional two-way fixed effects model, which means that we got time invariant individual fixed effects and individual invariant time fixed effects. We have the alpha GIT here, which is called group fixed effects. So you can use the alpha GIT to cluster your cross-sectional units and get a time varying group specific fixed effects here. So you can address cross-sectional dependence issue, and you can use the model to cluster your data, especially in the area of macroeconomics. So the GI here treats each unit as group membership, and we assign them into the total number of capital G groups. And the assumption is that the capital G groups and the group membership, they are fixed over time. And the clustering algorithm, which is quite similar as the machine learning K-means algorithm, but there's some difference about that. I'll show later. And I think one of the powerful extensions about GFE is that we can, sometimes we have to break the homogeneity coefficient assumption. So we can use the GFE with the heterogeneous coefficient in the second equation here. We have the alpha GIT here, which is the group fixed effects. We can also have the individual fixed effects, and we have the beta GI1 and beta GI2, which is the heterogeneous coefficient, and it is group specific. But constant over time. So I know it's ugly, but I have to show you this. So that's how Bluebear helps me. So for the GFE algorithm, it is quite similar as the K-means algorithm. So let's skip the first step. Okay. So we first get some starting values for the parameter of interest, and we call this as an initialization process. And we just randomly assign each unit, each cross-sectional unit into capital G groups and set up the starting values here. And next step is that we need to update the optimal group memberships by the least squares here. And the next step will be we use the least squares to update the latest parameters about the theta and the alpha. So you continue this iterative scheme till it is numerical convergence. But as you can see, if you use a starting value that and you check if you check the objective function, that might not be the global minimum objective function. So you have to use like many starting values to ensure that you get the global minimum objective factory values. So that's the reason why we need the first step. We can have a loop for the total number of capital R starting values to check if we got the optimal group membership and we got the optimal parameter of interest here. So at the beginning, I code everything in MATLAB in my computer, and I set the number of simulation, the number of starting values be 10 million. And from the basic statistics, I calculate the total number of time I have to stand is like 30 days for one regression. So I think I cannot pass that much JRS2 meeting and my PhD study. I have to get the results, the final result till my first 50 years birthday party. So I seek help from Bluebear to see if there's anything Bluebear can help me. And in Bluebear, we can use the parallel computing because in your own computer, if you don't set up the parallel computing, it's just you use the single core to compute everything in your computer. But in the Bluebear, I can use like 70 cores to compute this stuff parallelly. So instead of 30 days for one regression, I can just get the regression within like 5 hours. So I think that's it. I know. I think it saves me from my supervisors. So how Bluebear helps econometricians? As you can see, you can just put everything on Bluebear, and you can use your own computer for free, so that you can use your computer while you use the Bluebear to do your regression. You can use your own computer to read literature, to chat with other people, or even watch YouTube. It's okay. So and you don't have to worry about the crash issue Claire just mentioned. All right. Okay. So I have to be quick. And no matter what kind of programming language you use, Bluebear can always accommodate it, like Stata, Python, MATLAB. And you can use, from the perspective of the econometrician, you can use machine learning and Monte Carlo simulations with parallel computing to save your time. But it's the situation in the Department of Economics. What if you are a student in management, marketing, accounting, or you are currently use qualitative research methods or some basic quantitative research method? Luckily, I consult my girlfriend, who is a first-year PhD student in the Department of Management, and she enlightened me. Like nowadays, more and more mixed methods are popular in the top journals regarding accounting, marketing, or management. So there's a conversion from the traditional data to the big data process. So even you don't use the machine learning or some advanced quantitative skills, at least you can know it from Bluebear. Because you can maybe start, you can start knowing it by use the Bluebear training here. Bluebear training provides many Python, MATLAB, and Stata, Python MATLAB training here. And you can always use the research data store, which is very fast and secure to, save your data, just in case your computer is crashed or your hard drive is crashed. And you can think about, if you don't use the Bluebear at the current period time t, you can always use it in the period of t+1, t+2. So you can treat it as an investment for your future potential research, so that you can use it smoothly and easily regarding machine learning and AI in the future. Okay, that's all I want to speak. Thank you for your guest. Thanks.
Thank you. Good afternoon, everyone. Today I'm going to talk about how machine learning and econometrics can help with my environmental economics research. So I'm Bowen, and I'm a research fellow at Business School. So we all know that econometrics and machine learning are about learning from the data, but they differs in terms of the goals, methods, and settings. So econometrics is all about identifying, detecting, and summarizing the relationships among our data. For example, we use linear regressions to produce the parameter estimation. So we call it a model-driven. However, machine learning aims at the pure prediction problem. So we fit a set of predictors to predict outcome variable of our interest. So we call it the data-driven model. So in literature, there are multiple ways to combine econometrics and machine learning. The first is we use a machine learning model to feed in the data for econometric analysis, like probably like Claire did, use machine learning to do the text analysis to create some variable. And secondly, we borrow some econometrics techniques to enhance machine learning algorithm. For example, we can use the causal inference to help with the machine learning prediction. Third is we can use machine learning techniques to enhance our econometrics. This is what my focus is. So lastly, which is the most interesting and challenging one, is that we can use both techniques in a new way and a high level. So we can have one model that can solve both econometric challenges and also machine learning challenges. So this is still ongoing research by researchers from Stanford and Harvard. So today my case study is going to talk about the winter heating and air pollution in China. So this is our new paper that's going to come in EST. So we all know that in China, we have centralized winter heating each winter in northern China. So which is the major source of air pollution, right? So in 2017, the Chinese government had realized and issued the clean winter heating policy in China. So after 5 years later, we're going to evaluate whether this clean winter heating policy work in terms of improve air quality in northern China. So here's the map to show that we have two treatment groups. The first treatment group is the black dots. We call it 2+26 cities surrounding Beijing, Tianjin, and Hebei province. The second treatment group is all the northern cities with the red dots. We call it the northern cities. So our control group comes from the southern cities located far south in China because they have no winter heating, so they can serve as a potential control group. So our methodology motivation first is that from the atmospheric science perspective, understanding the effectiveness of air pollution control policy is challenging because air pollution are directly affected by weather conditions and the emission strength. So it's very hard to understand whether the improvement of air quality is due to the emission reduce or is due to the weather, right? So from the economics perspective, we care about the causal impact. So we use a lot of econometric models like IVDID or static control to identify the causal impact under the causal network experiment. So with these two motivations, our approach is to combine these two steps. So first step, we use a machine learning model called weather normalization to remove the impact of weather from observed pollutant concentrations. So the left figure, what we observed, it's very large, but after we remove the impact of weather, we can see the true impact of the lockdown, which is this large, right? So for the second step, we use weather normalized data to feed into the synthetic control method, where we use for the causal inference. So this is from the Abdai 2010, so very famously synthetic control method. So our random forest model is we use for the weather normalization. So this random forest model is a very powerful model to predict pollution levels using a lot of predictors. So our predictors including time variables and the weather conditions like temperature, wind speed. So our outcome variable is hourly city level air pollution in 190 Chinese cities, right? So this is an advantage of the machine learning. So we are able to understand the drivers of air pollution using explainable machine learning. So for example, for the left figure, it tells us how important each predictor is in terms of determining the level of air pollution. So for example, we see that temperature and humidity are very important in terms of this pollution impact. And also temperature, humidity, and OX are important in terms of determining this haze episode, which is a pollution event. So for the right-hand side, we have both the main and interactive effect of all the predictors on PM 2.5. So due to the time, we can discuss more privately. So this is just to show you how machine learning is powerful in helping us understanding the drivers of the air pollution. So these are our main results. So after 2017, the Chinese central government implemented the clean winter heating. We can see a huge change from of SO2 from 2015 to 2016. Each time during the winter, the pollution can goes up to 40 units. After 2017, the peak reduced to only like less than 8 units. So it's a huge reduction due to this clean winter heating policy. So we also have the result of all the other pollutants. So this figure shows us how each city performed in terms of this clean winter energy. So for example, the PM 2.5 pollution due to winter heating in Beijing reduced by around 11% due to this clean winter heating policy. So this is just to tell us how important for government to design this kind of policy to have benefit for clean heating, for cleaner air and better public health. So again, this is what I've used machine learning and econometrics. So if I use my own computer to run this model, it takes several months, 2 months, 3 months. But if I use in BlueBear, I submitted multiple jobs. It only take me 2 days, right? So it's also BlueBear is a powerful tool that helped me to doing my research in a large scale. So I think this is my talk today. So please ask if you have any questions for all the speakers today. And hopefully our talk gonna give you some flavor in terms of how machine learning can be applied in economics, in business school research. And this will be amazing tools for interdisciplinary research in business school. Thank you so much. Yes. Yeah. Yeah, confounders. So economic development, energy structure, population, all these variables can be confounders. Our method of synthetic control is to construct the counterfactual using a set of a control unit that by literature, we can discuss later. Yeah, I would discuss to you. Sure.
We've got to leave the room, so for questions and answers, we can carry them on outside. Otherwise, thank you for coming, and see you again.
Yeah. Thank you so much, guys.